Huh? Me? I didn't know.
He didn't say much.
Why is he putting AirPods and sitting inside class? Give on. Huh? So Friday at least you give all day.
What?
So
What have you been? What actually worked out from 4 to 6?
why do we have class every day, sir?
The question is what you have?
Badminton at 6. But I'll be tired. So actually we have plans tomorrow. You have to go to temple. I said KK to call you.
KK will be in the car.
KK doesn't give class on Friday.
Yeah, Friday is going.
I'm strong.
Yeah, we go. Oh, yeah. Stop.
Secure.
Okay.
One gap. Yes.
Yeah, we go.
What do you mean? What?
Don't move that.
You guess it, you not guess it. You're given this.
Instead of R, instead of CHC, I put
If I write this, if I say
to check if you use that calcium salt or fatty acids. Done that. Then ozone is done. Rosenman also done, right? Next one.
one guy will give me
How fat is the guy?
hey, that is other guy. This guy
He's short. Oh, he's fat.
is
They deserve the place. He deserves that place for you know.
how much he deserves to after finish it.
Just keep it down.
This is even after if you gain, you sit here.
Oh my. Hey, that's your. Hey, Naren, what's that? Got the word, huh? Okay. Okay. By the hydration of.
Sir, wait.
Hey, sir, I got a second. Put a map per house. Look at that. Map. No, which one?
She dropped me.
Which one?
She showed me two. Yours and
No, I say. Yeah, I was.
let him come to our area, then let him.
By the hydration of alkynes.
So, one minute.
Alkynes.
What is preparation?
Huh?
During preparation of
Alkynes. Which one on Kodara? Usually don't alkynes. Correct. Why? Why only alkyne? Why? Hydration of alkynes. Right, hydration meaning we add what? Water. In presence of H2SO4 concentrated. H2SO4 dilute. Just don't add anything. It means by dilute because if you use concentrated, obviously no what's going to happen. It will dehydrate. Exactly. So focus here as how it works. Yeah, wait. Break this up. If water breaks down, what and what? H plus as well as OH minus. Very simple. You have two things. distribute among both the carbons. So the first H goes and sits on the first carbon. Automatically, the second OH sits on the second carbon. When this is happening, the triple bond becomes a double bond. So CH was already there. After one H goes and sits there, it becomes CH2. The triple bond became double bond. CH was already there along with OH. Okay, so again, we are trying to prepare aldehyde. CHO is what I wanted. So don't you think this extra H is there? Fine. Now what has to be done here? We observe the pattern here. CHO is already present. It's just that it has an excess H there. So think of a way to remove the H and shift it to the other place. Okay. So the only way which can be possible is the concept called as tautomerism, where one can get shifted. So obviously this hydrogen, because excess or extra, goes and sits on the other carbon. Now CH2 becomes CH3. The triple bond became the triple bond became double bond. The double bond now becomes single bond. Why? Because CH3 is there. Wherever carbon goes, 4 bonds. Out of 4 bonds, 3 bonds got used up. How many more bonds are there? Single bond. So you put one single bond. The H got transferred from this carbon to the other carbon. What is remaining? CHO. Instead of writing this, as I told you, we'll draw it. I'll write CH3 as it is. Put a single bond. I'll put C, double bond O, single bond H. Nothing but some kind of aldehyde. From here to here, only shifting is taking place. The shifting is nothing but one sort of isomerism called as tautomerism. The reason we stop here is because I've achieved whatever I wanted. I wanted some sort of aldehyde. It is here right now. It's just that one excess H was there. Think only about either eliminating the H, which was not possible in this case. So I moved the H to the other carbon. This is what I did. You know, okay? No. So H goes to 4 here. Temperature.
570.
Give me 270 is only for conversion. 370. Getting it? Again, see, I have a small concept. Yeah, just a just. Today's class will be learning a lot of named reactions. I'll tell you how I remembered it. It helped me. That's there, but so basically, from chemical properties, it becomes difficult. No, I had a trick to remember the whole concept. Like, just remember that. Correct.
What is it?
Tautomerism. Tautomerism. Depomerism. I like just like it's a type of isomerism where you shift things to make it more visible.
Basically, you make a base of the solid for the three minutes, and when you keep it alive, you can find like three salts.
Okay.
At one shot.
Sir.
Give you the flame.
Correct. Based on the color, right? Should you mix the paste with it?
Yeah, concentrate it.
Do one thing. Next time, what is the lab? Take the salt, throw it. Right? You get the same answer. Don't mix it. So basically, you're trying to take the salt, mix it with the original solution, make a paste out of it. You're using some time there. You'll use around about 25 minutes. Don't do that. Take a spatula. Observe the thing. Maybe the spatula has 2 sides.
Give us the sauce.
Only just one side it has. You're in your college. One like a spoon it will be. Use the spoon side, not the pizza side. The spoon side. It takes out the front. Throw it at the flame. Or fill it with the spatula. Keep the spatula on the flame. So when it burns, it burns with the flame. Same. It's easier. Obviously the teacher should see. That's there. So fill it up with the spatula.
So when she asks for confirmation, then I'll show the answer.
Then you show. But you're doing this initially, no. But the actual procedure is good at the end. The confirmation is done at the end, no. But you're doing it
basic because it's longer.
Can you do that?
No.
No, see, the advantage here is, the disadvantage is, if you do the acid first, let's say you got group 2. When you learn the double final exam, let's say you have 8 salts. Out of 8 salts, you will know, give me some names for acid additives. The answer is what you have. Carbonate. Let's say carbonate is your answer, or whatever is your answer. You will know that for your final exam, based on carbonate, there are 2 salts only. Calcium and zinc. Example. So either the thing will be calcium or zinc. But the problem if you start with the basic article is you won't have this clarity. You will try for everything. Now let's say calcium and zinc both belong to group 2. Then don't solve group 1. Directly go to group 2. We're doing basics. You'll say So do acid because it's easier. once you get the answer, you should remember, okay, carbon will have only one and two songs. Then go to that specific group directly and use. That's easy way.
In your class, everyone.
Manganese, you can see the color at it.
In your class. In your class.
Hey,
everyone
what is scale
has
thing? Correct.
Are they in the same?
So that Danesh, so basically just by finding sulfate, you realize only 4 salts are there, 3 salts are there.
One guy
Out of which you can
finished-
start eliminating. Aluminum belongs to group 3, this belongs to group 2. So don't do group 1, group 2 for basic. Then you get it. Solve. And you will not know, the teacher will not know shortcuts at all. Or just spend 10 minutes of your time.
What would tell
Yeah,
you?
you're-
Tell you.
Just spend 10 minutes of your time. Yeah, your table is called as what is called as your eye.
Yeah.
Okay. Your workstation.
What
I think you should do acid that if it was systematically.
No, systematically knowledge. Just keep doing whatever you feel.
So for basic.
No, first do acid. Once you find acid, then you can change the order for basic. Because you'll get to know. See, for example, carbonate meaning in a syllabus only 2 salts will be their example.
Yeah.
Let's say both of them belong to group 3 in basic. So one getting it. So
Yeah.
acid you found out carbonate. So carbonate in the syllabus was A and B. And A and B, both of them belong to group 3, you know that. So instead of doing group 1 and group 2 for basic, directly start off with group 3.
Yeah,
Because
that only I do. I don't get it.
I
So we can't take a Raman from next lab.
take a book and go next time for exam. What obviously at this point of time you should know.
Don't.
You still haven't learned solid analysis? Alright guys, don't play around with the what do you call practicals.
You have to
That how
learn
much am I
everything.
performing in theory? See, now don't, all these are rumors and myths where they tell minimum the teacher should give you 24, nothing like that. They can give you 16 also. Okay, so keep all these things in mind. It is not like a 10 standard board where minimum amount of marks has to be given to you. Nothing like that. These people have their own rules, own set of rules. Depends on your behavior while working also in your lab. So make sure that you guys perform actually. See, what happens, do not play around in your labs. Like during the lab, perform the experiment. Okay, especially physics. You will not know how the setup is. Especially when it comes to users of wires. No, you will not know the wire is going from left end to right end. Why are they only using red wire? Why aren't they using black wire? All these things will come into picture. Black wire, I mean in physics also talking about, has to be used wherever there is 0 volts. It is called as zero potential. This is the rule. Let's say an external came into picture. I'm talking about a final exam, and use red wire or a yellow wire to connect the 0 volts to a specific circuit. You're gonna get 0 marks. Understand this? It's the color code has to be maintained, or else you're losing a lot of marks. And make sure you guys don't perform all these mistakes, because if the wire goes wrong, they stop looking at a circuit also. Without even thinking twice, they tell the circuit is wrong, which might lead to you guys losing 5 marks. So keep all these things in mind. You lose 5, what's the whole point of getting 70 or 70 or writing the exam? It's important to score a practical also. It's important, very important. It
Yeah,
is.
they didn't tell.
There also be, I'm not confused you because I used to use a Springboard, because I used a breadboard.
No, like this year we started using C.
Only for few experiments, but throughout the year I used to only use Springboard. Breadboard I'm not sure of. In a Springboard, they used to count the number of black wires. It had to be 2. That was the hint for us. Don't think of this. Well, for me, because only for my thing. If it was either 3 or 1, is to cut marks, because we had to ground 2 things. One is from the voltage to the thing, and one more from the circuit to some other thing. We had to ground 2 things. Yeah. The CR example, I have to ground the CR also sometimes. Then I should come and count. Okay, number of black wires used is 3, so therefore cut 2 marks. This is now specific there. If you're using less, maybe they might excuse you, but if you're using more, then 100% cut marks. And red is always for those the stone is actually working. Yeah. The current should pass through it, or something should pass through it. That's why it's supposed to use red. So a huge concept there. I think IC is the easiest to be honest. But not, I think microprocessor also is easy. Just sitting and typing things. You feel very lucky to get that.
I still didn't do that.
What is the percentage of getting parts for both?
They're also-
Of getting
they're
parts.
ideal.
They have that. I think 3 marks in the first MCQs. No, potato, wooden. Nothing is commodity. It's like,
Sir, your 40% that practical mark only practical teacher, okay, or your subject teacher also.
both.
Subject teacher also.
There are 2 people sitting. One is from your external, whatever.
So, before they give no for the record and
That is your lab picture. Your
Whereas both are same. Actually,
them correcting a record is your teacher. 6 marks is your teacher's hand. The remaining 24 marks is there in both their. So it's 24 marks to perform on that day, that morning. 6 marks you're doing throughout the year. You're writing record and all
That
that.
lab picture is
You can't expect the same lab picture. For example, let's say a physics department has 4 teachers. Out of them 4, one of them can come and sit in. It need not be your physics teacher. It can be some other physics teacher, but if she belongs to your college, it's fine. That's the whole. That's the problem. That's the whole point of, because your teacher might give some tricks.
You have to show the circuit and not to the external.
Both depends on how lucky you are at that point of time. Usually the external walks towards you and comes. Your in-house teacher, college basically, they'll be sitting there only maybe to ask questions based on Viva, maybe, but they are there to assist them. All the questions, the marks providing part is usually by the excellence. That is to remain unbiased, but how things happen. Just that pressure. New teacher at the same time is asking you some random questions.
chemistry Viva is meant.
Depends. No, you're supposed to pick up chicks.
Yeah, that's okay.
See, for me, Christ teacher came for electronics. For them, they use breadboard. You use springboard. She came and told, she carried a breadboard. She gave the breadboard. She's like, can you replicate the same diagram on this board? She asked. I don't know. I haven't seen a breadboard in my life. And she's coming and asking fit it. There's some kind of pattern to fit the breadboard. I didn't know how it works.
Positive, negative.
Exactly. I didn't know all these things. Springboard is what we make the connections. For breadboard, she asked. I told her, I don't know.
How do you connect resistors? You have to pull that thing.
See, the springboard, the board is neutral. It's wood. It's an insulator. So you keep 2 springs, which are conductors. You attach a resistor between the 2 points, point A and point B. And let's say to the left end, if you connect positive, that automatically becomes positive. You are the deciding authority, because resistors do not have terminals. No? So you can give it positive, you can give it negative. But in breadboard, you should assign those things depending on however the patterns.
So the semiconductor expense followed by should be there.
Correct. Because breadboard is impossible. So circuit is so much. 100 wires are popping out. But just, I mean, end of the day, just make sure you guys don't mess up your practicals. Next heading, from nitriles and esters. Write a statement. Nitriles. Spelling you guys don't know, it's not nitride. Nitrile. I-L-E. Careful. Cl basically. Okay. Nitrile reacts with tin 2 chloride. Tin, open brackets, Roman numeral 2, chloride. And HCl. To form an imine. Careful, imine. I-M-I-N-E. I don't know what it means, but later. Which on hydrolysis gives an aldehyde with ammonia as the byproduct. This reaction is also called as, or is called as, Stephen's reaction. It's not Stephen, it's Stephen. This reaction is called as Stephen's reaction. I'll give you 2 types of it, the same reaction. You choose whatever you guys are comfortable with. Let's read the sentence and let it convert in terms of chemistry. It says nitrile. So RCN. Don't write. Plus, tell me, nitrile reacts with what? Tin 2 chloride. Correct? along with to give what? Imine. Amine is what? When R is connected, okay, fine. Ammonia is what? NH3. In this ammonia part, if you take off one H and add an R, it becomes RNH2. Agree? This is called as an amine, which is the next chapter. Getting it? This is ammonia. What is changing is the number of hydrogens there. If one hydrogen gets replaced with one alkyl group, it is called as an amine. But here, let's say I keep the R there itself, I keep the N. Instead of writing H2, if I only write H, it is called as an imine. Pathological how it works. Now, later, not in this chapter, okay, later, maybe somewhere around, somewhere in carboxylic acids. Okay, you learn something called as an amide, AMIDE. Under the same concept, also learn something called as imide. So the reference is the same. What is changing is the number of hydrogens. That's all. Okay, but the structure might change. Nobody cares. But what's the difference between amine and an imine is the number of hydrogen atoms. All the other things will remain the same. You know, okay? No. It has technically yes, but right now I won't tell anything. Technically yes, because wherever n was 3 bonds, 1, 2, 1 was equal. I tell you where. Copy this somewhere on the margins. Header somewhere. Enough. This is what's going to happen here. R, C, I copy paste. Okay. I put a double bond, I tell you why. N and H. Check. NH is there. So the answer is imine. Here. Imine. But we'll think in one more concept here. Ignore the R. Talk about this carbon. Wherever carbon goes, how many bonds? 4. Right now. Okay. For that. Wherever N goes, how many bonds? 3. 2 bonds here, 1 bond here, N is satisfied. What about H? Satisfied. R satisfied. What about this C? It needs how many more bonds? 1 extra bond. There is nobody to come and assist it. Hydrogen. Now, if you think here, do we have some excess hydrogen? 100% yes, because HCl is a what? Acid. Acid keeps on producing what ions? H ions. So automatically H comes and sits here, which means the actual thing looks like this: R, CH, double bond, and H. Any doubt here? But how I wrote was, I wrote C, double bond, and H first. Then you start thinking, what and all is missing? Only 1 bond with respect to C was missing, and we got the answer. So this is the first step. Now continue. Which on hydro? Okay, this is the imine. After the imine, continue with the statement. Once the imine is formed, which on? Hydrolysis. 1 second. Hydrolysis meaning addition of water. You obviously know what happens when water splits up. It forms H plus as well as OH minus. I'll pause for a second here. We are trying to learn which chapter? Aldehydes. Which means my answer should be aldehydes. Cool. Let's try to get it. Now focus. Don't you think this will become a crazy bond here? Because NH2, they are already together. Okay. Now, whatever I circled, you might ask me, sir, why aren't we trying to break the bond between N and H? Why are we trying to break the bond between C and H? That's a very good question. Reason is because, ask yourself this question. Between this C and this H, how many bonds were there? 1 bond. Between the same H and nitrogen, how many bonds were there? 2 bonds. Which one is more easier to break? The single bond. Okay. So I broke the single bond, compared to the double bond. Right now, there's absolutely zero connection. That's what I call it just. I still don't know how it works, because in a double bond and a single bond, if you ask me, this bond only is easy to break. Correct? Not this bond. Because sigma, that attachment first here. So do not learn it that way. I'll tell you how to remember it. We are trying to learn something called a Stephen's reaction. Stephen's reaction come only in aldehydes. We want aldehyde meaning what? CHO we want. Fine. It's already there. HO is there. To make this an aldehyde, what is required? C. C is already there. So I take off this part. I attach it next to C. It becomes RCHO. I won't write it like this. I'll draw the thing. But these two combine and form NH2. But don't you think one H is already there? NH2 combines with this excess hydrogen and forms also called as ammonia. Stephen's reaction is the only place until this point in organic chemistry where we get ammonia as the byproduct. Getting it? Again, you can ignore this, but if you ignore it, you won't understand this logic. Okay, so understand it was easier to form CHO compared to whatever. So you break it down and then form. Please do not write RCHO, always draw it. Or C double bond O single bond H. Has to be mentioned. Imine has to be mentioned. How many schools, colleges are coming this chapter or started this chapter? Started. Did they come across something called as dibal H? Huh? What's the full form? B is there. Aluminium. I tell off everything and keep repeating. Why is the big improving? Lip sync to it. Next building. They're cutting trees. Actually, that's not cutting trees.
You're an eco club, no?
No, not equal.
This is okay, if that's something that this is.
Under the same heading, instead of using all these excess, listen, instead of using all these excess things which you obviously can't remember, there's a direct way. You take the nitrile RCN and subject it to obviously a catalyst. It's called as dibal H, all our caps. This is what I'm supposed to write it. Listen, di isobutyl aluminium hydride. Getting it? Di isobutyl aluminium hydride. Now what happens when RCN is subjected under dibal H? It automatically becomes RCH double bond NH, also called as imine. So it's a one-step process. Without trying to add anything else, we get the answer as imine. Now, how do you convert imine to aldehyde? On hydrolysis, where H plus and OH minus comes off. This both will combine because it's a much more stronger product. This RC will attract to OH and form what? RC double bond O single bond H, also called as an aldehyde, plus wait. H and H is already there. This is nothing but NH2, not that stable. It attracts H and becomes NH2. So the main difference between the previous one and this one is the amount of reactants used. Here I'm only using the main reactant and subjecting it with a bigger catalyst called as, what's the name again? T stands for di. IB, isobutyl, ALH, aluminium hydride. Do not learn it like this. Even though there's a hyphen between L and H, learn the last letters are together. Second two letters are together, D. Okay, remember that. Technically, yes. Because we want the answer to be the same. Any reaction is based on the answer, not the reaction. Because if you see the first reaction, the main reaction is the same. RC and RC.
But they ask Stephen's reaction again.
But preferably write this. Yeah. If you go to college, they'll be like, preferably write the essential too. No, what logic they'll tell. I mean, it's a good logic. Stephen's reaction starts with what letter? That's why he's essential to that. It's a good logic, but depends. Hey, that's the only way you guys can remember, guys. Don't be, don't feel ashamed to have some lame tricks with respect to chemistry. The more kiddish the tricks are, the better you'll be able to remember it. Okay. What came across? Something you came across now? What did you find out? Next heading. No, one more. Catterman-Koch reaction. I'll write it. Catterman. G-A-T-T-E-R. G-A-T-T-E-R. M-A-N-N. Hyphen. Koch. C. Not C. It's K. K-O-C-H. K-O-C-H reaction. These people are all more of European. Yeah. Ayn Rand.
Sound like that.
Praise philosophy. Ayn Rand. Friedrich Nietzsche.
Yeah. Fyodor Dostoevsky.
Stovsky. Called Vegetarian. Huh? That's what Ayn Rand. Okay. Segment right on. Benzene in presence of carbon monoxide and HCl with anhydrous AlCl3 as a catalyst. Repeat that. Benzene in presence of carbon monoxide and HCl with anhydrous AlCl3 as a catalyst gives benzaldehyde. AlCl3 gives benzaldehyde. Most important reaction. It's easy. Okay. Benzene. What are the reactants? Carbon monoxide and HCl. Balance of AlCl3 gives benzaldehyde. That's it.
How do you remember? But,
Gatter. I actually have a quick break. One second. I've given something for this thing. What's the second name then? KOCS. No. I tell you. This is what I think I told first batch. I forgot. See, the thing here is when you're writing a final exam, you will not know which chapter it belongs to at that point of time. 100% will be getting confused because you're learning around 14 chapters for the final exam. Catterman-Koch, look at the first word. It looks complex, agree? Fine. According to you guys, the first time when you guys came across organic chemistry, that was the most complex looking compound, agree? So benzene was the most complex looking compound when you guys started with organic chemistry. Now everything is more complex, but that's how I remember. So that end, the first word, since it looks complex, we'll start off by drawing the most complex looking compound when you start with organic chemistry, which is nothing but benzene. Okay. Second word says what? Koch. Ignore the K. OCH. Interchange it forms CHO. Okay. So benzene benzene end of the day forms under aldehyde called as benzene. Okay. But the first word is difficult. It's kind of kiddish, but you're supposed to remember it. Looks complex. What are the first complex looking compound in organic chemistry? Benzene. Start off with that and then get the answer. Okay. In fact, I thought you guys will ask me the thing. Catalyst. Everything is right there. Okay. So the second name is useful. So basically, CO you'll use, CH also you'll use, one letter is remaining H. What is the basic most acid which starts with H? That's it. Now, you wrote HCl. Yes, all are interrelated. So you start off with catamaran, which looks complex. So benzene. Then ignore the K. Everything else is kerosene. You should know. You got to split it up. CO is the carbon monoxide. H is remaining. What's the acid? HCl. If HCl acid is there, AlCl also has to be used. Now, what's the final answer? OCH is there. I'll interchange CHO. Attach it to whom? The benzene. How to remember where to attach it to? Before this, what word is there? Catamaran. Catamaran look complex. So benzene. CHO should be attached to benzene. That's all it is. Okay. I hope you guys will remember this code.
Yeah, mine's a big one there. HBD.
Hey, we made a trick on Zain Malik. I forgot. I think I don't remember this. We sat there. Tomorrow exam is, I think, Christ model exam was going on. 1 o'clock in the night. I'm sitting at home. Aram is there. Online, this one is there. Everybody is there. And they come up with something. Okay, fine, let's do it. We came up with the trick at that point of time because they had their exam tomorrow. It's crazy. Many times. Forgot the trick. I think they remember. Last time. Okay, next heading, chemical properties. Telling you that this is the most difficult part. I'll tell you as to how to remember it. Hopefully, you guys will remember. It starts from. Okay, first I'll tell you a small glimpse of the story. Okay, then you guys remember it. Physical properties when it comes to aldehydes is 1 mark important. Okay, so is 1 mark important, nothing else apart from that. Chemical properties is where the actual game changes. Now, till whatever you guys have learned, there are few named reactions, but least. Catamaran code is there, one more thing you learned. Rosenwald reaction we learned, all these easier ones are there. We have some tricks to remember these in terms of individual tricks. Here you can't do that, okay? Because these always, for example, when I talk about chemical properties, always remember, see, aldehydes between a textbook, okay? Such a big chapter. Let's imagine the chapter is around 50 pages. Till 20 pages, whatever we've learned till now is there in depth. Okay. From 21st page to 50th page, it's only chemical properties. Only chemical properties. It's so huge. But understand, bottom line. Okay, sir. Okay. So basically, chemical properties. Understand, there are 5 things. How many? 5. Don't overlearn it at this point of time. This is a glimpse. This is a summary of the story. First one goes like this. Remember the story, guys. First one is always nucleophilic in nature. Second and third, redox. Meaning, second one is reduction. Third one is oxidation. Fourth one is with alpha hydrogen. Repeat it. Alpha hydrogen. Also called as aldol. Aldol. Okay. Last one is clemensins. Or Cannizzaro, both of them are same category. Cannizzaro. Okay, I'll repeat the 5. Now, I'll have to go, deeply into all these 5 obviously at one of them. But remember, when I use the word chemical properties of aldehydes, 5, see, alcohols, all these things we learn. But nothing was as important as this chapter is. So, how to remember? Chemical properties mean there are 5. We start off with nucleophile or nucleophilic reactions. Second and third is what? Redox. Guys, 2 and 3 is what? Redox. 2 means reduction, 3 means oxidation, 4 will be alpha hydrogen, also called as aldol. 5th one is clemensin, but easier is Cannizzaro. Okay, don't remember clemensins because the clemensin comes in one of these parts only. Remember Cannizzaro. Okay, so we start with what? N, nucleophile, then we come to redox, reduction, oxidation, then alpha hydrogen, also called as aldol, then it is, I told you not to remember, Cannizzaro. Cannizzaro. What's the thing as how it works? Can you write the 5 in order? One is nucleophile, right? Just remember nucleophile. Nucleophilic reactions. Second one is 2 and 3 is? No. Remember the order. Redox I told you, no? Okay. First, you should put water. Okay. Correct. I got affected, but not in the same way.
Standard chemistry does this big reason for why you should put acid first.
That was what acid cloud. The cloud before. 2 anti-redox. Fourth one is alpha. Alpha hydrogen in brackets aldol. Don't remember aldol. You get confused. Because under aldol there's something called as cross aldol. What do they remember? So alpha hydrogen. Fifth one is Danisaro. CA-double-N-I or NA-N-I double Z. Something right, I should sound the same. Danisaro. Canny. Yeah. Many are there. Got the logic as how it works? Now, obviously, when you look at the chemical properties, it only says 5. Why is it difficult? So don't get scared. Each category has around 5 to 6 reactions. 5 to 6. Each one has, so totally it will be around 26. Getting it? That's the reason as to why this concept is important. But remember the 5. Also remember a few things I'll tell you right now. Repeat, okay? Don't ask any question at this point of time. You'll get all the answers when I'm solving it. Hydrazine always converts to hydrazone. Hydrazine converts to hydrazone. It's never zone first. It's always zine first and then zone. Just like imine first and then amine. Getting it? Hydrazine first and then hydrazone. All these things. Okay, I mean, please remember this. Wherever double bond O is there, CH will be formed. Okay, wherever double bond O is on the left hand side, right hand side, CH will be formed. Okay, remember this. And one more trick I'll give you. What's the, without looking at your book, in this property, what's the second property?
Reduction.
Correct. Reduction, we will be learning 6 reactions. 6. What? Out of 6, there are only 2 categories. One will form alkanes, one will form alcohols. So, since reduction, I mean, in this properties, reduction was what number? 2. Therefore, it will have 2 types of answers. Only 2 types. Others might have more. But reduction, you only have 2 types. The first type is alcohol, the second type is alkanes. You know here? No. So 2 and 2. Zine comes first or zone comes first? Zine. You should not stop at zine usually. And you're supposed to convert it to zone. Okay, remember this. You will understand it later once I start solving the questions. Hemiacetal becomes acetal. Repeat that. Hemiacetal becomes acetal. I tell you as to hemiacetal. Yeah. Hemiacetal looks like OR and OH. Look at both of them. This is supposed to be some kind of alcohol. Correct. But if there are 2 OH, it is not called as acetal itself. It is called as some kind of diol, alcohol. But here if you see, there are 2 different categories. One is where alcohol is involved. One more case where OR is being involved. Where R is the what group? Alkyl group. R is the alkyl group. But if it is OR, it will be called as hemiacetal. Okay, sorry. Okay, acetal group. Now, totally, it has how many ORs? 1 or 2? Therefore, it is hemi. Just like semi, it is hemi. Now, by chance, it looks like this. It's complete. No, acetal. Getting it? Hemiacetal becomes acetal. Similar way, instead of me writing R, instead of me getting the answer as aldehyde, if I get ketone, example, because both are same chapter, no. It will be called as hemiketal and ketal. What the logic how it works? Hemiketal and ketal. When? If it is a ketone being formed. Okay. If it is an aldehyde being formed, hemiacetal becomes hemiacetal becomes acetal. If it is ketone, hemiketal becomes hemiketal becomes ketal. What the logic how it works? So to revise chemical properties, summary, how many types are there? 5 types. First type is nucleophile. Second type reduction. Under reduction, we expect how many types of answers? 2 types. One alkanes and alcohols. Cool. Third type is oxidation. Fourth type is alpha hydrogen. Also aldol reactions. Fifth type. You know here? No. Heading: nucleophilic substitution reaction. Don't Ahmad. Yeah. He's always studying. In what he started studying. Under this, we'll have 5 reactions. Now which one? Nucleophile. Okay. First one. Again, guys, I will not write 2 different reactions for aldehyde or ketone. Instead of to summarize it, I'll write carbonyl group. Correct? No, because both aldehydes or ketones, the day we started, I told both of them belong to some kind of carbonyl group. Now, don't write. Under nucleophile, first reaction is with HCN. I'll give you a small hint in nucleophile. Write this hint, open brackets into the heading and write this hint. HCN, CN, cyano. Break the positive and negative. Or break into plus and minus, right? It's easier. Break into plus and minus. Break into plus and minus. You write, I'll explain. Yeah, under that, first one, I mean, in bracket, break into plus and minus.
Over the bonds.
Keep changing. If you want to make it as an aldehyde, make it as aldehyde. Ketone. So if you use aldehyde, hemiacetal. Ketone, hemiketal. So it is your choice. 90% of the time use aldehydes.
So we can just write R.
It becomes ketone. Leave it as it is. Again, it's your choice. There's no thing forcibly. Whatever you feel. Okay. This is the first thing. Okay. Now focus here. How to learn this? What does the hint say? Break into plus or guys, plus or minus. You tell me. Look at both these places. Which one do you think is easier to break? The double bond here or the single bond between H and C? How? But it's the thing with oxygen. If you break it, what are you going to do with oxygen? You'll eventually break it, but you won't start with the main reactant. Always the additional product is what is supposed to break. The common sense. You break this because of the hint. Break into what and what? Plus and minus. You tell me, after breaking this down, what gets a plus? Automatically, what becomes a Cn minus. Now understand, nucleophilic substitution, no. It's like sun rays. Okay. Remember, let's go back to your days where you used to enter all these drawing competitions. How we should draw the sun? Draw on like this. 1, 2, 3, 4, 5. Agree, huh? We've never seen a sun like this, correct? At this point of time, because you can't see the rays at all. And have you guys seen the complete sun later? No.
Because we're always like
No, I'm just trying to ask you. Have you seen the complete sun?
one side.
I don't know. I couldn't see the sun only. It's clear. You see the complete sun?
Look at the sun. You see half the moon is the sun. How do you see half the sun?
No, that's a logical thing. No, half the sun only. No?
You can't see. Can you see both the sides of man and one side?
No, correct. No. So this is the front view of the head. But it's called as head.
So if you walk in a circle.
It's a 3D. Okay. So basically, this looks like rays. By the end of the day, we know that in the solar system, what's the center? Sun. Similarly, you think only in this compound. What can this in? Carbon. So you put carbon as the center. Automatically left, there were 2 things, 2 rays. 1 and 2. Don't fill it. How many bonds were there? 2 bonds. Common sense is, wherever carbon goes, how many bonds follow? 4 bonds. Out of which 2 is drawn. How many more required? 2 are required. I drew it. But automatically with this carbon, 1 was already attached. What was attached? Oh. You choose one of the bonds, wherever, either top or bottom, your wish. Oh. Whatever was there, I flipped it. I drew it like this. Now focus. Carbon is kind of getting satisfied, completely fine. Wherever oxygen goes, how many bonds follow? 2 bonds follow. But right now, how many bonds does it have? 1. It needs how many more bonds? 1 more bond. You think about both these things. Which one is eligible to get 1 bond? H or Cn minus? Automatically, H more than 6 next to whatever. The O. This place was vacant. Correct. Who comes with it here? Cyanohydrine. Cyanohydrine. Hydrine or hydrine, whatever. Cyanohydrine. Okay. CYANO hydrine. Don't write. Just tell me if there's any doubts in this. No? Don't write. Wait. Sure or not here? Next. Same carbonyl group I take. In this case, I'm going to react this with NaHCO3. SO3. CO3, if you take note, it's a very easy compound to break. Now you tell me, we start up again. It's a nuclear substitution reaction, which means what's the hint? Break it to plus or minus. What is easier to break? Second part. You tell me, after breaking, Na becomes a plus, HSO3 becomes a whole thing with a minus. Now, what was the hint? Sun rays. Solar system was the, in the solar system, sun was the center here, carbon in the center. Those two rays as it is, the double bond breaks, becomes 1 and 2 like this, out of which O will arise automatically. How does the trick go? Wherever O is there, 2 bonds are required, out of which 1 bond is there, 1 more bond required. Okay, one more hint I'll tell you. HSO3 comes and sits here. But you write H here and SO3, the answer is wrong. Think, because carbon distant is what? Hydrogen. It will attract only the H part, it will pick off the SO3 part. Don't make that mistake. Either choose S or O. If you write O, you should not write O3SH. Wrong. Only one O it can attach. So, since a lot of rules are there, attach the S directly. SO3. Got the logic here? You note that? If you write H, it only attracts the H part, SO3 is kicked out. You shouldn't do that. So, and if you write the O, there's nothing wrong. You're supposed to draw the bonds there. Why? SO3H. Easy. Need out here? No.
But it's the same thing, no?
It's the same technically. But if you think from carbon's perspective, my best friend is hydrogen, I'll only choose that and take off the SO3. Okay. I can break it because I'm carbon. I can do whatever I want. Okay. Next one. Distance. R dash I'm using. Oh, now don't ask me, sir, what's R dash? Some other sort of alkyl group, that's all. Okay. Now we start off the break with what part? Okay. R plus R dash plus L2. Correct. And OH1 minus, careful. O R dash and 1L. This is called as this now OR and OH, which is now learned. Hemiacetal, correct? Or hemiketal, depending on whatever I take here. For example, if I take H and H here, it's an aldehyde. If I take R and H, again it's an aldehyde. But if I take R and R, it's a ketone. Correct. So if it is both R's there, it will become hemiketal. If it is an aldehyde, hemiacetal. Okay, that depends on you guys. Now let's say I got the answer as hemiacetal. I told you a trick. Hemiacetal will always get converted to acetal. Now to this, I'll add water. Water breaks down into H plus as well as OH minus. Agree? Huh? Now what can be done here? RO, it is about to add alcohol. Again, alcohol. Again, this breaks down to form R plus as well as OH minus. OH minus always wants to become water. For this to become water, it needs boom. H. Is hydrogen present here? No. It looks for hydrogen here. Is it present here? Yeah. So it only attracts whom from here? H from here. But what remains? O remains. Wherever O goes, how many bonds? 2 bonds. 1 is here. How many more? 1 more. OR dash and this is OR. In this case, both OR and OR was there. This will be called as. Getting it? So can I tell I'm using the same alcohol twice? Agree? Alcohol is being added first to form hemiacetal. If I'm satisfied with this, I'll stop here. But usually, won't be satisfied. I'll use one more molecule or one more whatever of alcohol. I get this answer. Convert in terms of acetal. Read out here.
You can directly put the 2 RO and
Explain how.
2 RO and then
Explain.
like that.
Exactly. Even they won't understand.
But it's correct.
What did I tell right now? 1, 2, you're getting the answer. You should go step by step. I'll do one more example later. Understand? Okay.
Yeah.
Can we write this?
What happened? Carbonyl group react with what is this? Okay, but if this breaks down, R minus MgX plus, correct? No. No. Yes, correct. Grignard reagent is always ulta. Okay. I told already, no. Magnesium is there to give it positive. It's there to guard it. Common sense. Carbon 4 O. O is negative. It attracts positive. OMGX. It becomes getting it? Whatever. Okay, so we'll react. No, one second. We'll react this with water. Water, it breaks down to form H plus as well as OH minus. What forms? No, think for a second. Automatically,
MgX will come out and H will go there.
correct. So this MgX pops out and reacts with whom?
So we'll get the same thing again.
One second. If MgX pops out, say it comes to the what side? The plus side. Plus will attract whom? Negative. It forms what? MgX. So it's a useless fellows. How many times I told you? Grignard reagent. The adding part wants love from both the sides. So it will such a now I tell MgOHX. Correct. Now this was there, which means carbon remains as it is, R remains as it is. Here O was there. MgX popped out, reacted with OH minus. O was there, wanted one more bond. H. OH is there. Correct? So first we react with whom? HCl. Second we react with whom? NaHSO3. Next is alcohol. Next is Grignard reagent. It won't form it. We are not trying to learn about aldehyde here. We are trying to learn what happens. We are using an aldehyde in the starting. What's wrong with you?
Okay, tell the next thing again.
Okay, first one. First one is HCl. Can you hear the first one with HCl?
No catalyst.
Shut up and write. Wait.
Not reagent is still there. Second one.
Yeah.
Second one. Not reagent is
NaHSO3. Huh?
not reagent backward.
That hint was so good, no? It requires love
So
from
go
both the
back.
sides. Oh, going back.
Please.
Not go back again. Never look back. Can't go back to the same story again and again. You know the story, no?
Yes, sir, but first one. First one.
First one comes back.
No.
It always comes. It tries to come. Nah. It comes back. NaHSO3, second one back.
Third one.
Trying to come back.
Yeah, chemistry.
The nuclear substitution.
ROH.
Yeah.
ROH.
Go back.
You should not go back. I'm telling means you're telling go back. I'm telling. Hey, Mantika. Hey, you're right, yeah.
I forgot.
What if I forgot? What is there? Split the negative and positive. Attach. Sun, you remember sun?
Should see what is that?
That helps you put next to
Same thing.
No.
At the same thing.
What? First one reaction.
No, personally, you know. Fun, none of fun.
Last one is Rignard's reagent.
What are you using for, huh? You showing the phone, like, yes, sir. NaHSO3.
Huh?
NaHSO3. Alcohol, ROH.
Second one is it's the second one.
HSO3. HCO3 is
Sir.
carbonic acid. No?
It's the second one.
NaHSO3. You might have. That is the last year's recording, yeah. Hey, you put on the driver. Hey, Putra, okay, drive on you sent me.
After this,
ROH.
that video full moody was.
What's the name?
We had drink that day. Then water.
If you know.
Hey, wait. Yeah.
This.
There no.
Hey, to take that she won't learn.
What learn? I'm asking the name. You only didn't tell the name.
Right.
This one.
Which one?
Second.
The second one name. What's the name?
You will ignore the name.
The reaction with alcohol must get no. After seeing what's the product?
What OH minus here? It's less than
Sure.
no putting size in it. It's a compound. Who's telling you water? I told you to drink water. Huh?
Now what? ROH.
Right.
I wrote that.
What's the second?
Third one is ROH.
With what else?
Yeah.
Last one.
No. Oh, are you poor?
But it's not
Okay. One hour is from here.
it will be OMG.
That is arrow. That is arrow.
ROH plus H.
Product.
What is it?
What is it?
This plus
M.
H.
How did it find the product? After adding
Okay. OH and one is R.
Water. That is the Jesus favorite.
What did I do?
I don't know. Rashik.
Yeah.
He didn't write anything. Yeah.
Third one.
So what reaction tell? Get her into.
Get
Get her into.
Next. Third one.
First one all. Correct.
The name I did.
Fine. Correct.
Name is compulsory.
Yeah.
I like prepare that name that you want.
So you write next one, sir.
51.
Next.
Then
Sir, next. Sir, next.
give it as example something.
Sir, next.
Hey, wait, I'm done, guys. Son. Right, Ra?
Sir, can't say.
Next one.
Shut up.
Angle is good.
Next one.
There's no H2. I don't know what it is.
What no exit? What is it? What? X square in X square.
I don't know.
X is X.
Huh? What?
X into X.
No.
So show that not really.
Sir, I didn't understand this.
Darkness.
Sir,
Please the dark.
sir,
Only the dark.
sir, don't. This part.
Yeah, go to the next one.
Wait, I telling something. What do you want?
You want that then.
What is it like? After 10
Because of Ebola, I didn't understand.
Every time I come.
He kept on talking something.
He didn't talk actually.
He was repeating whatever you were telling.
He was answering.
No, he was repeating.
So what part you didn't understand?
Last part.
You add the same thing.
That's right. After that.
You break it up.
You know that.
Then it becomes two things. One becomes positive, one becomes negative. The negative one will get surrounded with the positive one.
Can you stop
Why is
laughing?
laughing? I don't know.
Everyone's laughing.
You are laughing.
It's good.
He's everyone.
I always laugh. Laughing increases the lifespan.
Drinking decreases.
Yeah,
Hey, very important for you to give your message right now. Balancing.
reactance is equal to products.
Ooh.
Yeah.
R
Fridays
plus.
they make biryani.
R plus and OH minus. Listen. R plus and OH minus. Look at this. Okay. OH minus wants to become water. So what else does it require? What does it want? OH minus now to become water.
H. You shut up and write.
H. H.
It
It gets the H from
Say next line, I understood.
So R was it?
Yeah.
Correct? This is what then?
Grignard.
So candy zero, you are telling candy zero candies.
Reply is arrow. Can is arrow. We wrote can is arrow.
No, I wrote candies. I can candies.
Candies.
You focus on Grignard reagent.
The X becomes positive.
Okay, in this case, X becomes positive. Because it's along with Mg.
Okay. I know, sir.
So X can never be positive. Zero. Because positive, it wouldn't be an X. After. Which one are you talking about? Double minus C, triple minus. H minus minus.
We had 3 bonds to take.
Yeah, 2, 3.
Bonds to take.
What's happening now? What one is going on peacefully or what? Yes, it is. It's token number 4. That's how I feel he saved his name goes. Like what token number 1?
Straight up 5.
No, 1. Why repeat a secret?
On the Google Calendar, full it will be blocked.
Right now? Red ones for
Country-wise,
East.
you got the
Yeah.
I wonder what Germany like.
Alright. Done now?
The fifth reaction.
You don't fight.
Not that. We changed it from last
Well, drink start, sir.
Me? I am so fucking fucked up. No, it's not. Let's see. Stop. Alright. You pay that?
After the
They're fierce.
Previously. After the previously.
What do you tell?
With that reagent, MgX minus.
What do you tell them?
You won't understand.
I will understand.
You made them after every. What do you understand?
After every.
Doctor. Why some rape case happened? It seems doctor only raped like. See?
Why are you laughing? No, why are you laughing? It's so many days now. Now it's so many days.
What?
Story.
Why are you laughing?
Everyone's laughing. Why?
I didn't
No
laugh.
one laughs.
No one laughing.
You're also laughing too.
Because you laugh. Yesterday I told some death stories. They go, why are you laughing? She told. Yeah. But yeah. Reduction.
I didn't even do anything.
Why are you laughing again? This is after hours. Look back.
I want you more.
Huh?
The family.
We still don't know the fourth.
Very good. That's not that.
So 2 hours are there. Existence.
You don't even know.
Oh, that that's in last year.
Oh, lithium aluminum iodide it is. Happen the birth of nickel. This is nickel.
Nickel and dry platinum, palladium. Yeah, actually.
Lindlar's catalyst is palladium. Palladium with PaSO4. There is no L only in Lindlar. Is it?
I thought LM.
Think, why would you think?
Arrow. What?
Oh, guys, very simple.
Ketanol.
Alcohol. Ethanol will become, ketanol will become alcohol will become. Listen up, guys. Look at the first one, H2, which means it's supposed to have 2 hydrogens. One here, one on top. Now, all these things will result in the same answer. So, they will change these. Alcohol is the answer. Right. So, under reduction, 2 sets. The first set is this. And the first set, 3 reactions, which is the same answer. We'll not know. A reduction gives us 2 types. One is alcohol, one is alkanes. Alcohol partner. It will be the alkane.
Split them. I think I don't know this that the alcohol.
Oh, why you need to run?
Hmm?
Why you need to run?
What, Alex? No, ask him. Right here.
It's expensive. Food is not that expensive.
The third is so fucking wrong. Oh. What I take this guy history then. The transaction history. Transaction.
Swiss bank?
We run out the 10, 18, 18, 10.
Pens, no? 1880.
10, 2, 10.
Lifetime. Next.
We'll do everything today on the I forget everything.
1880, you remember, no?
Yeah.
Yeah.
That's a long.
Hello?
Hey,
Okay, from that time.
Talking about 100 years.
That bells.
100 105% or not there. Yeah, finish.
You wrote the product or you?
Hey!
The same product. Oh. Same reactant, same product. What's the point? No, hurry.
That's what I see. That's of your watch.
It's 2 it's 2.
Yeah. But the bond will be between the ends, not the chip. Great phosphorus.
And
Okay, listen up. Simple. You write R, C, R dash, ignore the O. Okay. We added the what in this case? We added H2, no? Throughout we added H2, H2, H2 everywhere. It's just that there was a distribution of both the H's. Okay. Here, you will add H2, but right next to this. Getting it? So you write R, C, R dash, ignore the double bond O. You will add H2 in both the cases. In the previous case, it was a distribution. Here, it is together. That's all. Okay. So it vanishes to form water. Okay. CH2R. Listen, 1 second. All these three things are alkanes. Alkanes. But out of these three things, first one and second one has a name. Okay. Clemenson's reaction, Wolff-Kishner. Any of these names, what's the answer? Alkanes. Okay, either Wolff-Kishner or Clemenson's. The answer is alkanes. How is it formed? Using obviously, ketone or aldehyde. We come back here. In both, so basically, okay, in very simple language, I'll tell you. In one sentence, explain what is reduction? Addition of hydrogen. Hydrogen is what? H2. In the first case, we distribute the H2. In the second case, we ignore the O and we write H2 next to this. If you don't ignore the O, it won't be called as alkanes. Remember this. Okay? You're supposed to take off the O there. Here, when it comes to this alkanes part, two reactions have a name. Clemenson's as well as Wolff-Kishner. Both of them are forming alkanes. The last one doesn't have a name. Remember.
How do you remember the second one is to do a
Yeah. And addition. Simple language. Imagine I cut off the O. H2 only. Correct.
How do you remember the reactions for anything?
So, O. Backwards. First one is called as zinc amalgam. First one, the ZnHe. NH2 and H2 is mine.
Yeah, next time you hear cement, you're told.
I don't know. Very great video. Very powerful. I sent you in which month?
Last year, October, then I think
Jan?
Jan or December.
You have that recording on that ABC chemistry.
Maybe.
We did morning, like two reactants form A and then don't have.
I'll tell you when the sort of the same thing that I attend. Almost every other organic chemistry will happen.
I use marks in that. I don't have.
4 options are there. Options. MCQ.
No, they'll ask in 3 marks.
Hey.
I certainly told. Yeah.
Okay. Then I'll tell you easy way. Organic chemistry is divided into multiple all chapters. So they won't mix haloalkane with alcohols. So if I tell you question number 5, it's only alcohol, haloalkanes. 6 means alcohol. 7 means aldehydes. Example. So let's say answer 6th question, which is the which main alcohol member. Answer will be alcohol.
Finish giving us this question from chemistry.
I think the people. Would like something.
That's it.
Again, that's the best.
Tomorrow is very.
Sir, actually,
How would you so?
I'm wondering online.
Right. You when I went on. Okay.
What? Shut up.
No college. What?
Eat your tea.
Stick class.
That's exam. One day.
Monday, Tuesday, Wednesday, 3.
No,
We didn't know. Okay, Monday to Wednesday, it's only 3 days.